presentations. I'd like to welcome everyone. We have 6 presenters tonight, and they have a variety of themes, so we'll have some interesting presentations, I'm sure. So each presenter will have 15 minutes to present and then 5 minutes for questions and answers. And I'd ask that if you do ask a question, please type that into the chat window, and then the presenter to read the question so the question gets recorded in the recording. All right. So with that, first up, we have Brentley Marzen. Brentley, you're all set. So whenever you're ready, please go ahead.
Hello, everyone. I will be discussing the spatial relationships of honeybee populations and colony loss in the US um, from 2015 to 2024 today. So before we jump into all that, just a little bit about me. I got my bachelor's in computational mathematics from Embry-Riddle Aeronautical University. After graduation, I went to work for Textron Aviation, who's the manufacturer of Beechcraft and Cessna aircraft. I started working for them as a quality data analyst, and earlier this year, I moved into a field support business analyst. So I'm supporting a lot of our field service representatives that go out and talk to the customers about the planes they want to buy and the issues that they're having. And then just a little fact, I'm a big outdoorsy person, so one day I hope to through hike the PCT. So starting to get into a little bit more of the project. So my focus was to evaluate the historical trends of managed honeybee colonies in the United States. Um, there's becoming more of a reliance for managed honeybee colonies in the US because of crops like in California, almond crops, they have to be pollinated in order to produce an almond. So therefore, there's becoming a reliance on yielding as much of that as they can. So they bring in managed honeybee colonies either on property or transport them there to make sure they can get the highest yield possible. So monetary value wise, this industry is growing. Um, the actual pollination services yield about 250 to $320 million a year. And then honey production is also recorded, and that gets about $330 million a year, as recorded in 2017. So it's a pretty big industry. And the USDA has collected data on it for a couple decades now, and there's still a bit of a lack of reporting of that data and being able to see what that data is doing over the last couple decades. So this led me to the research question. What are the spatial distributions of the honeybee colonies and their colony loss throughout the United States? So some literature review, getting into what information is already out there. The only established research I could find when trying to answer this question, and specifically looking at the United States, was from the Be Informed Partnership. They're a private organization. They conduct their own individual survey that looks at colony loss. It's a lot of word of mouth, filling out the survey, no regulation, or it's kind of spread by other people who are already filling out the survey. And all the reports that they release on them is year over year. So we just got that one comparison from one year to the next in all of their reports, but they have been reporting on this for about a decade now. So after that, moving into seeing what other countries or other organizations around the world are doing, I ran into these two organizations who do their own surveys. One is obviously a lot bigger. They cover a whole continent and then a couple other countries in there. But they all do about the same thing as the Be Informed Partnership do. They look at year over year when they report, and all of these surveys that I'll talk about today are very similar in the kind of data that they're collecting. So this led me to dig into how other studies have looked at the historical data and how they map that. So there were two studies that I really focused on to help me try to figure out how I wanted to answer this research question. So the first was a research study in Bangladesh. They were looking at rainfall and temperatures, and the way that they showed that was doing a regression analysis with the least squares method, and then displaying the results of that trend that would come out to say what that area was doing. The other one that was a little more interesting to me because the Bangladesh survey, the temperature and the rainfall was very normalized data, so it was a little easier to work with. All the data I looked at wasn't very normalized, especially for time series data. It's not always going to be that common. So I really looked into this study on the Mann-Kendall trend test, and it's a great tool for time series data because it can be used for any distribution state. So this brings me to my data and methodology, because that's the route I decided to go for. So the data for this study is from the United States Department of Agriculture, and specifically the National Agricultural Statistics Service, or NASS. So NASS conducts yearly honeybee inquiry surveys and colony loss surveys to keep all of that data. They've been doing it since the 1980s for the honeybee inquiry, so just population, production, that type of stuff. And then they implemented the colony loss survey in 2015. So that's why this research starts in 2015, so we can look at both of them together. It's also a voluntary survey. It's not mandated in any regards, so there can still be gaps in data there. But all the data from this survey is mainly for operations with 5 or more colonies, and it's all stored in NASA's quick stats data. So the chart that you're seeing on the screen now is going to be all the information that was entered into that quick stats database to return the data that I used for this study. And it came back in a tabular format, which I'll discuss later on how that works with the project. But another portion that came out of this is they record that data quarterly. So in this study, it's each quarter is being associated with a different season to be able to kind of look at the seasonality of some of the data. So the area, so there was data for a lot of states in the US, but Alaska, Delaware, New Hampshire, Nevada, and Rhode Island did not have any data recorded in their database. And then Hawaii also only had a partial data set from 2015 to 2021. So they were also excluded in this specific study. So one of the first things I wanted to identify in the data was seasonality. I wanted to make sure that there was seasonality to the data because something I wanted to look into was separating those out to hone in on specific seasons trends. Winter isn't necessarily when you're seeing all the honeybees fly around. So it's one of the seasons that is most susceptible to colony loss and some of the specific issues that operations have with colony loss. So that just shows there that it is, and also solidified the decision to go with the Mann-Kendall trend test for this specific study. So once it was identified that that was the trend test I wanted to use, I needed to look at what tools I could use for that and how to translate that to be able to show that spatial relationship on a map. So luckily ArcGIS Pro has a really well-developed space-time cube tool set that was perfect for this. So a space-time cube is a data structure within ArcGIS that pretty much allows for a third dimension of data. In this case, it's going to be time. So you'll be able to hold data for the same place multiple times and have that time associated with each one of those bins. In this study, the time intervals, which have to be equal, they can't be inconsistent, is going to be 3 months. So each quarter split up. A limitation of the space-time cube is you have to have at least 10 data points in order to create one. But upon creation of the space-time cube, you can visualize it and look at the trend data, and the trend specifically used when visualizing a space-time cube is the Mann-Kendall trend test. So it was the tool that I decided to go with. So as I mentioned before, This trend test is ideal for the study because of its ability to be used on any distribution. Since I don't have a very normalized set, it was the way to go. In a Mann-Kendall trend test, the first bin is compared to the next bin. If the second bin is larger, equal to, or smaller than the result returned, you get returned a positive one, a 0, or a negative one, and then those are added up across to see if there is a trend in the data either going negatively or positively, or none at all, zeros across the board. And then with that, you also get your p-value and your z-score with that to say whether or not it is a significant trend. And then when it comes to visualizing the data, it is returned to show if it is a upward trend, a downward trend, and then what level of significance it has. So it only looks at it, it only visualizes it if it's within 90 or 95 to 100%, or 90 to 100%. So you'll get 3 different categories to see how significant that trend was. So wrapping this up and putting this all together, here's a little flow chart of the steps needed to make that happen. So the honeybee population data and the colony loss data have to get joined since they're in tabular form to a feature layer. So I'm utilizing census tract data that's already in Esri's database and joining the honeybee population and colony data to that. And then I'm able to feed that into the space-time cube creation tool using those defined locations. And then I can go ahead and visualize that and get back all those statistics for the test. So the results. When looking, so the results are in a series of maps of the United States. When looking at the following maps, purple will be displayed for the upward trends and green will be displayed for the downward. So first up is the annual population. So this is all the way from 2015 to 2024. So the purple displays the increase in the last decade, and a majority of that we can see comes on the East Coast. An outlier with that is going to be Maryland, and then Louisiana also seems to have a really strong decrease or downtrend in those populations as well. When looking at the annual colony loss, we can see that Alabama and Georgia are experiencing an increase in their colony loss, which is a little interesting to look at because in the previous map, the population was also increasing. So they have to be doing something there to combat their colony loss to continue to increase the population as well. And then we can see that there's that series of Midwestern states that are seeing a downward trend in colony loss, which is obviously a good thing. And then for this study, I got to split up the winter and the spring seasons to analyze to see if there's additional data that we could get in that. So looking at the winter population first, we can see some on the East Coast, some of those states popping out with the same trends as they were in the annual, but California shows a stronger decrease in population or a stronger confidence and decrease in population than what we saw with the annual. And then we can also see some of those other Midwestern states coming out in that their winter populations are increasing over time, which is something that we didn't get to see in the annual population one. So doing the same thing for colony loss. Colony loss trends in the winter do not display too big of a difference from what we saw for the annual one. But we can obviously see that everything's on a downward trend that does come out with significance, which is interesting to see Alabama and Georgia not express any specific trend up or down compared to the 3 previous maps. So that's the takeaway from that one. So then doing the same thing with the spring season displays an increase in population. This may not be too big of a surprise because it's the spring season, it's when everything's starting to flourish a little bit. So you're going to see a little bit of stronger numbers there, most likely. but we're still seeing a lot of the same patterns. The outlier here that comes up is North Dakota up there in the Midwest. Hasn't been seen on any of the other maps that we saw before. So just something that pops out in this focused trend analysis versus the other ones. And then looking at the colony loss for the spring as well. Um, there's no states that have decreases in the colony loss here um, that were in the spring, for the exception for Wisconsin. So these states show a pattern of those decrease in colony loss in the winter that aren't there in the spring. So looking at all that, there are definitely some future opportunities to continue this research. One of them is to complete this analysis for the summer and fall seasons. I mentioned before that one of the limitations was you had to have 10 time bins in order to complete the research. The 2024 data for summer and fall of this year wasn't released at the time that I was conducting the survey. So went ahead and tried it for the winter and spring season to see if there was even a point to hone in on those specific seasons. So I would say that there was items to take away, trends that you identified in some of those seasons that weren't in that annual evaluation that would make it worth your while to go and finish the summer and fall season. Something else to look at would be the duplication or gaps in data between the Be Informed partnership compared to what's here. They're both voluntary surveys. So it's likely that there is data in one and not the other, as well as duplication. But they look at things like operation size. So really small operations versus really big, that may be beneficial to see how the two data sources can work together and kind of fill in some of those gaps. And then to take it even further, it would be beneficial to complete an analysis on colony loss reasons. So the USDA does record what your colony loss reasons were. So it may be good to hone in on some of those states, like some of the unusual ones we saw, like Alabama and Georgia, that had really high trends, to see what their specific colony loss reason is, or if there's one that you can go tackle in those states and get more detailed to be able to actually have actionable items to go assist with the issue. So there I just got a list of sources and then my key takeaways again. So that's about all I have for my presentation, but I'm happy to open up for any questions.
All right, thanks, Brentley. Very practical investigation on something that we all need, right? Honeybee pollination. A couple of questions, but I'll start out with um, how does the bee colony loss data get reported? Is it self-reported, or are there teams that go out and look at this, or how's that data collected?
Yeah, it's all voluntary, so the USDA will send that out to operations that they know, but most likely you're going to go to their website and fill out that survey yourself. So it's something you do have to be aware of.
And that's only available at the state level?
Correct. Yeah.
Because obviously there's a lot of variation. If you try to look at a single state, it's painted all purple, but there's a lot of variation within that. So I was just curious to know what the spatial resolution was at that.
Yeah, I think they may have specific years that they get that granular level. I can't remember, but that was about as far down as I could go for the analysis, or like even looking through the data, because I would have picked a specific state to hone in on and see what the variation between, even if it was just like counties or regions of it.
Yeah,
But it
yeah.
didn't seem widely available.
And then one more question. So on your what was it? I think is the initial line graph showing bee colony loss over time. Yeah, that one. Nope.
That
Yeah,
one.
that one. Yep. So you see there's a seasonality, winter, summer, spring, and so forth, that repeats throughout. So there's a cycle to um, the bee colonies. But if you notice that 2020, 2021, and 2022, that seasonality is greater
Mhm.
and then it decreases. So I wonder, I mean, that was a period of COVID. So I wonder why that was the case. I mean, it just seems odd that it's no coincidence that you had a sudden increase in bee population during
Yeah.
COVID. So, and I'm sure you don't know the answer to this, but it'd be curious to know why that's the case.
Yeah. It could be, this is speculation. This isn't like based on any study that I've read, but I would guess that a potential reason could be since they only looked at operations of five or more in that period of COVID, there were people who just expanded their colonies a little bit since they had more time to invest in that kind of stuff. How to be outside, how to do stuff. I know people around here in New York who had hobby like bee colonies around that time. So that could be a potential reason. I definitely saw that it was correlated with COVID as well. But it's kind of hard to tell without knowing how many operations had, only one or two colonies beforehand, which is another reason why, like, that may be a gap that the Be Informed partnership may have data on because they look at the smaller operations as well as the large ones. So they might actually be able to tell that story better than the data in this study from the USDA.
Yeah, sure. So yeah, I mean, it could be just an artifact of hobbyists trying to get into it, and then COVID was over, and it's like, well, all right, I got to go back to doing other stuff, so I'm done with the bees, and then you have a drop in the data. So I don't know. I was just curious to hear your insights on that. So
Yeah. And that would also be another reason why it would be important to go look at the colony loss reasons because like colony collapse disorder that literally takes them all out at once could also very much be a factor that would do it. If all of your colonies go out at once, it's kind of hard to start from
yeah,
uh,
yeah.
step one again.
All right. I'll ask you to put your contact info, your email in the chat window in case anyone wants to have a follow-up question.
No, of course.
And then you can stop sharing. We'll let Tiffany get lined up here next. All right. We see your presentation. So Tiffany, anytime you're ready, you can begin.
All right, can everyone hear me?
Yes, you're loud and clear.
Awesome. Hi, everyone. I'm Tiffany Lopez. Thanks for being here today to watch this. Currently, I'm not in the GIS world. I work in the private education business as a director of a math-only learning center. I've been doing that position for about 9 years. I started off as an instructor, so the master's degree is a little bit of a different change of pace for me, and I hope to segue into this field very soon. I oversee about 25 to 30 employees, and I have 200 students across 190 families, so it's quite a bit to manage. A lot of mixed bag of customer service, education, marketing, that sort of thing. So today I will be speaking about my capstone project, which is exploring the spatial correspondence between ghost forests and red wolf habitat in the Alligator River National Wildlife Refuge of North Carolina. This project brought together three important topics and the relationships between them: accelerated sea level rise, endangered species, and wetlands. Oops, sorry, technical difficulties. Firstly, what is a ghost forest? A ghost forest is an area of dead or dying trees, as you can see in this picture. It's caused by increased salinization in the soil. This increase can come from sea level rise, or SLR, and high impact events such as storm surges, fires, and droughts. This is the focus of the study, the red wolf. The only place left to observe them in the wild is in the Alligator River Refuge in eastern North Carolina. Fewer than 20 are currently living there, which makes them particularly vulnerable to changes in their habitat. These wolves use forested wetlands for protection, hunting grounds, and denning areas. As sea levels rise and these forested wetlands transition into ghost forests or open water, this species, along with many others, will lose suitable habitat. The formation of ghost forests have a monumental impact on coastal forest retreat, ecosystem benefits, and on animal habitats. Sea level rise is accelerating, and it's important to study the effects on these coastal habitats so that we can help preserve these ecosystems for future generations of humans and animals alike. A study done in the Alligator River National Wildlife Refuge, North Carolina, saw that most of the ghost forest formation had occurred within a decade prior to the study, which was a sharp increase from the average up to that point. Many animals inhabit these coastal forests, and they may be changing faster than they can adapt to. Coastal forests are also areas where carbon is stored. It's a huge ecosystem benefit that will get lost. When these forests transition into ghost forests, there's no longer the same amount of biomass as before, and this carbon is released into the atmosphere, adding to the global warming issue. Many animals also use these coastal forest habitats throughout the entirety of their life cycles, such as the red wolf. These habitats, as they migrate either inland or converted to open water, plants and animals may not be able to adapt. Any changes could severely disrupt the normal rhythms of these animals and resulting in a decreased genetic diversity as landscape connectivity issues arise and wildlife corridors become fragmented, as well as loss of suitable habitat for denning and hunting and those sorts of things. While existing studies highlight the impacts of sea level rise in the transition of coastal forest to ghost forest, there is limited research that specifically examines the spatial distribution and habitat suitability of red wolves in Alligator River Refuge. This study aims to close that gap by providing a thorough spatial analysis of the correspondence between the formation of ghost forests and red wolf habitat. This is the study area. It encompasses the Alligator River National Wildlife Refuge in eastern North Carolina. It's in the red outline there. It was established in 1984 to protect a type of wetland known as moccasins and its associated plant and animal species. There's a wide variety of wetland types that are found there, including high and low moccasins, bogs, fresh and brackish water marshes, hardwood swamps, and Atlantic white cedar swamps. The whole refuge covers about 153,000 acres and spans two different counties, Dare and Hyde, in North Carolina. This is an overview of the initial data sets that I used in the study. Most of them were required for use in the model that I will tell you a little bit more about in a moment, called SLAM. And then the rest were used for the overlay analysis to determine the spatial relationships. You can see I had a variety of different vector and raster files, but in the end, all that was done and was used were raster files. And the final resolution of the project was a 30-meter cell size. What did I do with all of that data? So most of it was used in the model that I just mentioned called SLAM. It's the sea level affecting marshes model. It was developed in the 80s by Warren Pinnacle Consulting, and it's a free download. I didn't have to purchase anything, so that was really great. And it's available on GitHub, and it has a lot of different resources. In order to explore the spatial correspondence of ghost forest formation and red wolf habitat, I first had to model the change in wetland over time. So rather than using a typical bathtub model that just simply measures inundation levels as sea levels rise, SLAM actually models wetland conversions over time and takes different things into consideration, such as elevation, slope, and wetland data. And you can see up at the top, those are required files. And I also had an additional optional file, the percent impervious file, that also helped with the conversions. Over the years, SLAM has undergone a lot of improvements. There's a lot of different really cool things that you can do with it. I just didn't get a chance to dive into that due to the time constraints of this project. But this is the screenshot of the interface on the file setup screen. And then you can see I've already put everything in. It's really cool because if you click on this, it tells you whether or not it's in the same grid size and whether or not you've done something wrong. Initially, I had made a very large study area. And when I tried to run the model, my computer got very upset. So this calculates out to about over 1 million cells. And you can just imagine, because it's a very small portion of 2 different counties. And originally, I tried to do the entire coast of North Carolina. That was not going to work. I learned very quickly that that was not the right way to go. So this study had 4 main phases: an initial data preparation phase for the SLAM input, running the SLAM model itself, and then a second data preparation phase from the outputs of SLAM, and then the final overlay analysis itself. This is the workflow, the initial workflow that I used to create the inputs into SLAM. Generally speaking, all of the data sets that I used needed to be clipped, reprojected into a common system, put into the correct units, as some of them weren't in feet and they needed to be in meters. I had to take pretty good care to make sure all of the raster data sets that I used contain the same number of columns and rows for input into SLAM. They had to match the exact grid size of the digital elevation model that I used. The model also doesn't just take shapefiles as their inputs. I had to convert them over to ASCII files, which was quite a bit of a different tool that I've never used before. So that was interesting. Everything was done in ArcGIS Pro. And in the picture of this workflow, you can see I have green arrows for inputs, red arrows for outputs. So the inputs became the outputs, and there was a lot going on. The light yellow boxes are the tools that I used. And I tried to color coordinate everything. So from this slide, the colored diamonds, I have them up here on the top right screens to show you which part of the process that we were at. Probably the hardest part of this data preparation phase was the conversion of the National Wetlands Inventory data, which I'll refer to as NWI, into SLAM categories. It was quite an adventure. This is a partial screenshot of the NWI polygon conversion to SLAM categories. In addition to this sheet and the second page, of course, and a walkthrough Excel sheet provided by Warren Pinnacle Consulting, I used Google Sheets and a couple of formulas to turn each National Wetland Inventory category into a SLAM category. It was numerical 1 through 23. Not all of them were used, obviously, because not all wetland types were found in that area. They correlated to a single or a double-digit number rather than the set of letters and numbers that comes with NWI data. And then I used these new numbers in Pro in their own attribute file, sorry, their own attribute line. And then I used that to convert from the polygon to a raster shape file. In addition to the file inputs required by SLAM, I also needed a sea level rise scenario. So this is a screenshot of a table from Chapter 9 of the 6th Intergovernmental Panel on Climate Change report that I used to interpolate the sea level rise levels for the study's custom time series. Since the model itself hasn't been updated in quite a few years, I believe the last model scenarios were updated in 2009, and I was using this report from 2021. This was a very important step for accuracy in the model run. I used sea level rise estimations for a high emission scenario with medium confidence denoted by SSP-8.5 in the table, and I indicated that with a pink arrow. This is the screenshot of the custom sea level rise scenario that I used, calculating with the previous table and other literature. You can see that the baseline year I did not use for 0. That is because of the difference between the year of the table that I used of 2021 and the current year with the wetlands data that was updated in October of this year. So once SLAM was run, I had another data preparation phase to go through. For each of the years that I used in that custom time series, I was left with an ASCII file, and that ASCII file then had to be turned back into readable data. So I used another tool in ArcGIS Pro to turn that into rasters again. And then it did need a little bit of preparation. I had to use the integer tool to give it an attribute table. And then both the ASCII files for each of the years and the red wolf habitat underwent some reclassification before I even did the overlay analysis. And here you can also see green arrows for inputs, red arrows for outputs. The inputs became the outputs and vice versa, back and forth. The tools again are in the same color. So for simplicity's sake, I kept, and for the purpose of and scope of this project, I only chose 3 categories to reclassify the wetlands data because there were, out of 23 categories, there was 13 that I still had for each section, which would have been quite a lot to look at. So I grouped them together. I grouped forested wetlands together, those first 2 in green, which are used by the red wolves for cover, hunting, denning, that sort of thing. Then I used transitional ghost forests, which are obviously less desirable habitat, and I put that in light yellow. And then open water, of course, in blue. The red wolf raster also required a very simple reclassification. And then once that was done, I combined them together using the raster calculator for the overlay analysis. And it allowed me to identify areas of overlap between the wetlands and the red wolf habitat within the study area. So this is the result. It's a series of maps produced from the combinations of red wolf habitat with each of the outputs from SLAM for each of the years in the custom time series. The collection here shows each of the maps side by side with corresponding years and projected sea level rise above each. Green areas represent areas of forested wetlands and red wolf habitat overlap, yellow areas of transitional ghost forest and habitat overlap, and then blue for open water and habitat overlap. For each of the map, there is actually an equal area of no correspondence, equal to 44.71%. And then below each of the maps in the corresponding colors that match the legend as well as the table in the previous slide, are the percentages of each of those overlap types. So if you look at starting from the left in 2024 and moving right, there isn't much of a pronounced change in forested wetlands overlap. It only declines a small bit by 2035, and there's actually no change from 2035 to 2050. But from that point on, there's a drastic decrease of almost 12% in forested wetlands by 2075, and then a further 15.7% by 2100. That same general trend is seen with the second line, which is the transitional ghost forest overlap. It only rose 8.18% from 2024 to 2035, and it actually decreased a little from 2035 to 2050. However, once you go from 2050 to 2075, the amount of transitional ghost forest overlap jumped 11.44% and another 14.77% by 2100. So by the end of the century, it starts making more and more drastic changes, to correspond with the accelerated sea level rise. You can even just see by looking at the maps that there's a significant shift away from the amount of forested wetlands by the end of the century. You see a lot of green on the left, and then by the time you get all the way to the right in 2100, you see a lot of yellow to correspond with the transitional ghost forests. So those ghost forests are slated to form in areas where the forested wetlands overlap with red wolf habitat, leading to a gradual and then not so gradual loss of suitable habitat. Overall, there is a loss of almost 28% of forested wetlands, corresponding to an increase of about 26% transitional ghost forests and 1.6% of open water, if the conditions of the model are met with the high emissions scenario that I used. This drastically reduced coverage of forested wetlands indicates that Protective policies such as restoration of remaining wetlands, habitat connectivity efforts, and buffer zones to limit saltwater intrusion must be put into place to mitigate the effects of SLR on changing wetland habitats within the red wolf habitat range. So future research can include the use of higher resolution digital elevation models that I used. I used a 10-foot cell size for my digital elevation models because of the study area that I had, and the finer the resolution, the more cells I would have needed to calculate, which might have broken my computer. So I tried to keep it to a decent enough size where I could get a good overall glimpse, but the study could definitely benefit from some higher powered computers and much finer resolution data in a much broader area. This was just a small snapshot. Originally, I started off with the whole coast of North Carolina, and I obviously ended up with a very small portion. I also believe that a public use website with interactive maps and informative chunks of information would be of really great value for educating the general public on this important issue. I know a lot of public policy is trying to get the public to understand what you were talking about, and I think there needs to be a bit of a better push for public education in that regard. Before closing the presentation, highlighting some of those main takeaways, I just wanted to share some of the studies that I used to help build the foundation for this project. um, Overall, I did find a significant spatial correspondence between ghost forest and red wolf habitat identified within the Alligator River National Wildlife Refuge of North Carolina. By 2100, there's almost 28% of forested wetlands within red wolf habitat that are projected to be lost and transitioned into ghost forest or open water, resulting in a drastic reduction of suitable habitat. The study also highlighted the interconnected impacts of climate change, sea level rise, and habitat loss for a highly endangered species. It also underscored the need for integrated management practices for conservation and preservation of critical habitats in North Carolina, but also this is a good snapshot of all coastal areas. So it's not just for North Carolina or the US, but it can be applied to a lot of different coastal habitats. Well, thank you for learning about this project. I'm sorry if I spoke a little too fast. I do that when I'm nervous. But now the floor is open for any questions you guys might have.
All right, Timothy, thank you. You did fine. No worries. So do you know, I mean, it was clear that by the end of the century, you're going to have massive change in the land cover percentages in your study area. Do you have any idea as to why there's such an accelerated change in the latter part of the century?
So the IPCC, the Intergovernmental Panel on Climate Change, they come out with reports every couple of years on a lot of different factors that play into accelerated sea level rise. A lot of it has to do with so I used a medium, I used a high emission scenario with medium confidence. So it might be a little on the high side, which is one of the limitations that I did mention in my final paper. But honestly, it has a lot to do with carbon emissions, right? How many fossil fuels we're using, the amount of building that we're doing on coastal cities, and then you have the storm surges, and it does tend to, in each of the models, it accelerated it even just a little bit. I did use a slightly higher emission scenario than I could have. Here it is. So this was a couple of different scenarios that I could have used. I did pick the higher end one, but I picked it with the medium confidence. I had been tempted to use the one with lower confidence, but each of these in the blue is a medium confidence. So not quite sure why it's accelerating, other than, human factors playing a huge role into global warming.
All right. Looks like you have a question in the chat.
Oh, sweet. I I feel like there's so many different topics to go around, that these capstones give us a good way to get into something that isn't necessarily, you know, talked about too much. Um, it is surprising that, not as much as talked about. Red wolves, there's only 20 of them. Actually, I think when I started researching again in the middle of my paper, there were 17 of them. And then honestly, there are some people that don't seem to care all of that much. They're like, well, why does it matter? And it's not just red wolves that are being affected. If red wolf habitat is being affected, then so is everything else, because everything's connected in the food chain, right? So as the little lizard is being affected, that could end up affecting the red wolves as well. So and also there's so many different species for people to study. I think it's just generally there's a lot of information, and we just necessarily haven't covered all of it. Thanks, Beth.
All right. Any other questions for Tiffany?
Thank you, everyone.
Yeah, if you could put your email in the chat window, that'd be great.
Yep.
All right. Up next, we have Elizabeth Carroll. So, Elizabeth, you can start sharing.
Yep. Can you hear me okay?
We can hear you fine. Yep.
Great. I got a new camera today, so.
Looks really crisp.
Okay. Okay, so hi everybody, I'm Elizabeth, and I used to work as a bond trader in Chicago before moving out to the Pacific Northwest, and then I ended up here in New Hampshire 2 years ago. And ever since I've been here, we've had a lot of really bad storms. They keep calling them the 1 in 100-year storm with a lot of flooding. And I'm really interested in birding. So I was just wondering what was happening to the bird habitats, what the habitats have looked like in the past. And that's really been the driving force behind this project. So I'm assessing salt marsh habitat fragmentation and sea level rise impacts along the New Hampshire seacoast. Okay. I've got to move this. So my research question is about how sea level rise drives changes in fragmentation and the extent of salt marsh habitats along New Hampshire's coast. And then what are the projected incomes or impacts on ecosystems and bird habitats? Let me just move that window. Great. So salt marshes are extremely important because they protect from storm surges. They're important for carbon storage, nutrient filtration, but right now they're under threat from sea level rise and habitat fragmentation. And this is one of the towns in southern New Hampshire where you can see it's right up against the salt marsh. And then on the other side, you've got more urbanization. So the goals for my project, I wanted to quantify historical change in salt marsh fragmentation from 1996 to 2010 and 2021. And then I wanted to assess current fragmentation. I used metrics like FragStats, and then I wanted to predict future impacts. But unlike Tiffany, I didn't use SLAM. I used NOAA's projections. And this right here is another view of one of the estuaries with the salt marsh fragments. So the objectives to support my goals were to analyze land classification and then to integrate some eBird data to assess some of the bird habitat vulnerability. There's a lot of information out there on sea level rise, on migratory birds, but I had a tough time finding things that were about the migratory birds in New Hampshire. And halfway through my project, I found this great report by or paper by Stevens et al. And where it's looking at the fragmentation within New Hampshire and specifically along the coast, but also a little more inland. So that was great to read that and have that kind of to support some of the findings I was getting. And then this bottom study was also really important too by Benoit and Naskins, because not all birds are going to have a problem with sea level rise and with the flooding that occurs. There's some, as the marsh migrates, there's some species that might actually do a lot better because they like to be along the edges. So, all right, so my study area, well, the New Hampshire seacoast, it's only 13 miles on this little inset map. You can see it. And I live in this area. It's, I guess what originally I was thinking, it's just 13 miles. So, you know, how bad can that be to really explore this area? And then it's got these 8 towns. There's the main border was the border of my study area, and then Massachusetts was on the bottom. And then this left side was actually I-95. I just copied that border. I thought that would be pretty good to just have a study area in between that boundary. And then I've got the coastline here. There's also a highway that goes right along the coastline too. But similar to Tiffany, I encountered a lot of problems with this study area still being a little too large. It's 13 miles by about 5 miles inland. So I ended up picking another area within my boundary, and this is the Hampton Seabrook Estuary area. And I just wanted to kind of take a look at it and see if I got faster results. And so originally I just looked at 1996 and 2021 for this area. And then in the next couple of slides, I'll show you, but I encountered some other problems with this area. So I ended up switching back to my original one and just really taking my time and letting my computer work. So let's see. So these are the main data sources I use. I had a lot of other files that were derived from some of these bigger ones. But yeah, I use the Landsat 5, 7, and 8. And then I guess I want to point out here, the eBird, I was really careful on how to use it. It has a lot of bias. There's a lot of several really great studies talking about the bias in eBird. And I've also personally experienced it. So unlike a study where a biologist goes out and maybe is looking at, you know, all the birds they see within a quadrant on a certain day, eBird is from citizens that are pretty much the same demographic. People might not always be honest where they're seeing the bird, if they're actually seeing it. And then you might have, you know, 100 people reporting the same bird. But it was all I had access to. And so I tried to be careful with how I used it. Okay, so the methodology, I'm not going to go too deeply into this, but basically I had the categories in the yellow, the data acquisition, then prepping it. That took me a while. I actually went back and forth with the years. And after I found that study by Stevens et al. 2023, where they focus on 2021, I thought that would be pretty good to use that date. So then I went backwards from there 25 years. I broke this down into my land cover classification, accuracy assessment, the fragmentation analysis, where I used FragStats and RStudio, my sea level projections, and then the bird habitat assessment. So let's start out with the refined area. This was the area within my bigger one. And so where I got into trouble was that for the first area, the original one, I didn't include anything like mud flats or bare earth. And I wish that I had. And water's supposed to be here, but it's not showing up. I realize it's the same color as the background. So yeah, I figured out, I just used like the raster calculation for the area and then the percentage. And that's what I came up with for the salt marsh. But where I found problems with this is that when I compared the years, I got the exact same amounts or values. And I had to go out to like the 100th decimal place to find a difference. And I was like, a little disappointed. I mean, I wasn't expecting a big change, but then I started realizing that when I built the boundary, I went a little too close to the actual estuary and I didn't leave any type of buffer. I could have redone that, but then I'm showing you this picture because I really started looking at the actual this estuary and realizing that with between the road and then the urbanization and the development, the estuary is already tightly bound. So maybe I would get some difference, but it was going to be kind of marginal. And so I decided to go back to my original area. So here we are. I'm not showing you the 1996 or the 2010 because it's just really hard to see the differences. But I did get some differences between the the 3 years, especially for for some of the other categories, but I'm focusing on the salt marsh. So then once I had this, I isolated my salt marsh area and I put it into, first I did the confusion matrix, which I got between a 68% and a 72% accuracy. And I thought that was pretty good. I was able to find some control points from USGS, and I was really happy with that. These points, it's hard to tell here, but they actually even went into the salt marsh in areas and they were in the water. So I felt like I got a really good score. And let's see. Yeah, so then I took the raster of the salt marsh area and I uploaded into FragStats. I'm not going to show you everything that I did because it was my first time using FragStats and I probably had way too many categories and different metrics that I was looking at. And they're all in my report, but tonight I'm going to show you the two main ones. So there were 3 categories. There was a patch, classic, and then landscape. And so right now I'm showing you the patch. I looked at the mean patch size and then the patch density. And so my results showed that from 96, there was a drop in patch size in 2010, and then it rebounded in 2021. And the same with the patch density, 2010, there was a difference. So in the end, I'm really glad I ran the 2010. It was extra work, but if I just looked at 96 and 21, I would have, seen, a little bit of a change, but overall, I would have said it's been pretty stable, which is supporting what Stevens et al. 2023 says. But with the 2010, I feel like it shows that within these years, you're going to have up and down. But overall, the salt marsh, it's pretty healthy and it's rebounding and it's doing what it needs to be doing. And that's sort of what other studies have found too. And then, let's see. So that was my 25-year historical look. Then I wanted to look 25 years in the future. And I went on to NOAA's site. They had a sea level rise viewer. I was able to find the New Hampshire coast, isolate it, download it, create my own file, clip it, and then create a inundation layer where I looked at I intersected it with the salt marsh area. And so the salt marsh area, I started out with 8,642 acres. With the blue storm surge that NOAA predicts as 2 feet plus a 1% storm surge by 2050, the salt marsh inundation is going to be 6,516 acres. So that means the salt marsh will be projected to lose about 24.6%. So while I was looking at the NOAA information, they also had projections for 2100, and the extreme value was 6 feet. So I wanted to see what that looked like. I kind of struggled here with how to show it, and I'm still thinking about it because I want to redo it. But I think so. This is the what's going to happen in 2100. It's going to lose 6,672 acres. Now that's of the original. So this is like not even counting the 2050. And when I tried to put the 2100 over the 2050, it was just too hard to see in a map. But I'm kind of wondering if like just how to show that. But okay. So I took those inundation levels I created, and then I went into eBird and I looked for the hotspot sites. And hotspot sites, they're just public access sites where people have seen a lot of birds. I looked for specific sites that had over 150 species for the last 25 years. And then I created my a CSV file for that and uploaded it here, and then intersected it with the other inundation layer to create my risk levels. So I had these two sites with the lowest risk, Parsons Creek and Henry's Pool with the most, and then the Hampton area, which was part of that first, not the first, but that more refined area was kind of a moderate risk. So I thought this was kind of interesting that you have a high risk in between these two lower risk areas. And this is where I feel like it would be really helpful to have some LiDAR to show you. But instead, I have this like aerial view I got from Google Earth just to show you that Parsons Creek, it's a little more open here. And so it's and it's hard to tell because the road goes over it, but it is a much more sunken area than these two other salt marshes. And then what I thought was kind of interesting was that this one, Alcoan Salt Marsh, the New Hampshire Audubon recently built a platform. So they must have looked at that too, a viewing platform. So I took one of the high risk areas, the Henry's Pool, and I went back into eBird, and I was able to get the frequency of observations for the last, what is that, like 29 years. And the species, one of the top observed species was the greater yellow lakes here. It's a shorebird. And none of these are really threatened right now, but they could be species that you could keep an eye on as sea level rise becomes more threatening. So here are my key findings. I have the projections 2050, 75% inundated, 2100, 77% inundated. The stabilization of the fragmentation trends, I thought after 2010, that kind of showed that the ecosystem shifts back to being a little more stabilized. And overall, for the last 25 years, it's been pretty healthy. And then the high risk bird sites were the Henry's Pool and the Parsons Creek. So recommendations, I would love to like look at this under LiDAR, especially along the seacoast. It's all pretty, you know, close to being, well, sea level, but there are definitely some little areas that would be interesting to look at. And then instead of the seacoast, I think it would be better to focus on the Great Bay Estuary, which I will show you. So this was my area right here. And right on the other side of the highway, you have the Great Bay Estuary. And this whole area right here that's shaded in, it's all considered part of the seacoast. So I think this area right here at the top, the Great Bay National Wildlife Refuge, that's what the Stevens et al. Report has focused on. And they're now part of the New Hampshire migration, the New Hampshire salt marsh plan of 2023. And they've also picked this area as being key for future restoration. So, thank you. That is all I have. If you have any questions.
All right, thanks, Elizabeth. Very telling in terms of doom and gloom for both you and Tiffany's future for habitat assessment, right? Yeah. So while we're waiting for someone to post a question, how, again, you know, you point out that salt marsh was pretty hardy between when you started and then, you know, the early part of your analysis, but then things took a turn for the worse. Um, is it just the case that the marshes get overwhelmed with inundated with salt water, or are there other factors
Yeah,
that are going on? I mean, I guess one of the things that why you were developing this proposal, one of the things that I guess I didn't impress upon was the notion of building codes, right? And how the actual building of homes and other things would harm or, you know, potentially do harm to the salt marsh environment.
yeah, I think for this area, it's the fact that since I've like moved here, especially in the last 2 years, we're getting more of these 100-year events. And so I think the last 25 years is going to be like the baseline. And it would be really interesting to look at like 22 to 24 when we've had like the most, I was looking at the comment. Yeah, we've just had these more and more extreme events.
All right. Yeah, you respond to Beth's comment, that'd be great.
I have to pull it up again. Oh, yeah, great. She's asking about the eBird data that you and I have talked about a little bit too. So eBird, it can be great, but people aren't always honest of where they're viewing the birds. So they might put it under a general like hotspot when really they're seeing it somewhere else. Birders can be very competitive. You are also not including all the sites of people not using eBird. So a lot of people, they just don't want to use it and they are seeing birds. So you're not capturing that. And then I guess the last big thing is that the demographics, you have pretty much all white, you know, a certain economic status, and people bring their own personal biases in. So, yeah.
All right.
Can I go here? Can you listen?
Yeah, go ahead,
Okay.
Marcella.
Elizabeth, maybe it's a follow-up question regarding the data limitations. With that, I think you say that you had to be careful using that data. So what specifically you did, or if someone has to use that particular data set, what would you say to account for that over-reporting or like the problems with the reports.
Oh, so sorry. What exactly do you want to know?
Like when you talk about the data limitations about this data set, you say that you had to work with that data carefully to account for the over-reporting. So I'm curious what specifically you did, or what would you suggest to someone who want to replicate this study and use that data set?
Oh yeah, great question. I've been thinking about that a lot actually. And one of the top birders she's the chief ornithologist for New Hampshire's Audubon, and she did a study on the estuary, my second area. And I think I would just reach out like to these individuals and maybe get their bird list. She has over 8,000. She's the top, yeah, really the top. And then seeing from that, like trying to maybe creating something. But yeah, great question. Thanks.
And then there's a quick follow-up from Beth that just popped up.
Sorry, it's like,
yeah, so she was saying that, so there isn't some National Wildlife Service database that's really good but hard to get.
no. And I tried, I think over the summer, for what is it, 586, I tried to use some other bird data, and the same thing, if it's done by citizen scientists, it's going to have some of the bias. Like it's different than if you go out with a biologist and you're doing an official study. They've got protocols set and certain equipment, and people are standing in the same site. And I've worked on some of those, but with eBird, people could be halfway down the road, or they could remember it the next day and then put in, oh yeah, I was there, I saw it. I don't know. It's just, I wish there was something, but maybe that's why we need more scientists in the field creating data sets.
Yeah, well, anything that's self-reporting is always problematic, right? Yeah. All right. Well, thanks a lot, Elizabeth. If you could put your email in the chat window, so if someone wants to follow up with you later, that'd be great. And then Matt Ray, I guess we're ready for you to present. You want to start sharing your screen?
Yes, thank you. All right, good evening, and thank you so much for the opportunity to for you guys to take the time to listen to my capstone presentation. The topic for my presentation today is referee assignment using spatial weight matrices. My name is Matt Ria, and I've been working as a geospatial analyst for the Air Force for over 3 years now, and I've recently transitioned into a project management and business analytics role where we're planning future strategy for our organization. Now, this topic may seem like a far stretch from my professional career, but it does hit close to home, as I've been a certified grassroots referee for over 15 years, which has really given me an opportunity to work alongside many different referee assigners, or the staffs within the leagues, and the different processes that they take to assign matches to all the different referees, as well as hear from my peers some of the challenges and struggles that they face on the field in receiving matches that they're willing to travel to, or that they're even wanting to accept given the nature of refereeing. And so that led me to want to look into what is the referee assignment problem. And fundamentally, it's the job and responsibility of the referee assigner to make sure that every youth that comes to play soccer has an equal opportunity to play. And to do that, they need to make sure that each match is assigned qualified referees that enable the match to be officially scored. And so while at the same time of trying to make sure that there is a satisfying experience for the youth soccer players, it's also important for the assigners to make sure that the referees themselves have a good experience within the leagues. And that goes directly against the issue of retention of referees in league. Yes, there are a lot of sideline behavioral issues that make being a referee very difficult, but how can assigners make the overall experience better for referees so that they can manage the stuff on the sideline and yet still feel satisfied that they're doing the job that they're wanting to do. So that's why one of the goals of this capstone was to answer my research question, which was how can spatial models leveraging spatial weights be implemented to optimize the referee assignment problem and reduce the cost distance each referee is required to travel to their assigned match locations. And to do that, a few goals and measures of success that I've set out were to calculate a cost distance matrix of all the referee addresses and fields, to design a graph database and store those relationships, and then build an algorithm to leverage that graph and identifying optimal matches for each referee. So early on in my project, given that we provide our assigners a subjective list of fields that we're willing to travel to, early research led me to read into distance perception and what that means for each person and the willingness to travel. And some of those reports were just talking about how our satisfaction of, or our perception of distance impacts our overall satisfaction to our work, to our jobs, and to the overall requirement to travel. Which led me to say, how do we improve that? So how can we use things like network analysis similar to how trucks are routed around cities? How can we use that to make sure that referees are optimally assigned matches using distance weight matrices? And then really looking at some of the studies around referee assignment problems themselves, it falls into a totally different domain of expertise with like operations research and how all these guys are trying to build models to say we can assign all of our referees with all these different parameters, but then when they get to the spatial parameter, it's just a plane ticket cost, or it's just, you know, the cost of a hotel to fly a professional referee across the country. And it does not help us as grassroots referees at all. So there's a gap in that, and we have to look to solve that. So my methodology follows three distinct phases. There was a data preparation phase, a distance calculation phase, and the cost distance optimization phase. Getting into the data, the scale of this project was of Franklin County and a few of the surrounding neighborhoods right around the border, to include some extraneous fields out on the perimeter. There were no authoritative data sets for most of these that were hosted in a geospatial format. So I had to go through and create a lot of these layers myself, which required me plotting, capturing latitude, longitudes. And then more impactful was there's a lot of restrictions on referee addresses and personal information about referees, given that a lot of my peers are youth referees. There are very clear guidelines for how we are to work alongside our youth referees. And to honor and respect that, I had to create a synthetic data set that captures a range of ages, a range of years of experience, and then join that together with a randomly sampled address data set of Franklin County to be able to get an actual data set to work against. Now, that directly impacts our ability to do some realistic pattern analysis, but for the purpose of this project, we were able to proceed. And then the last data point was the match schedule. So with a match schedule comes the time and date of which the match occurs, the location of the field, and then of course the two teams that are playing, which directly leads to the understanding of the age group as well as the division of competition that will be refereeing. So when I pressed with the project, I realized that at some point I'm going to have to determine which match I assign first. And so I developed a prioritization scheme that goes along a hierarchical nested prioritization using division, age group, and time, where the higher the division, the higher priority a match receives. We want to make sure that the most qualified referees are available to ref those matches, given their years of experience. So we wouldn't want to assign them to the bottom tier matches first, and then they wouldn't be available later. Same with the age groups with a similar mentality. And then for time, if we assign an earlier match at, say, what does this say, Alfred Reese Park at 8 o'clock, that referee's at that park, we can now assign them the 9:30 game, and it proceeds in that way. So once I got the data set ready, I was able to go into distance calculation. And to calculate the cost distance matrices, I utilized the origin destination cost distance matrix tool. This is offered by Esri. It uses a cloud-based, cloud-hosted routes layer that while visualized in a very Euclidean manner here that was for mostly rendering purposes, it did follow and trace the shortest path between each points. And each purple line on the chart there on the left represents a record in a table that stores both the time traveled and the distance it takes to reach the field. Now, when approaching this project, there were various numbers of tools that are available to me to be able to do work like this. I found some open APIs, and I was recommended some other SRE capabilities, such as the network spatial weights, things along those lines. As we look at scalability of the project, if I was an assigner for an entire region, reading some of the documentation on some of these tools, based on how the software developers develop the capability, there's some scalability limitations that come with certain tools. This product provided me a output that was user-friendly for me as I went to develop my further later algorithm. And so it was really useful. Now, it didn't present it in such a pretty matrix such as this, but I wanted to be able to utilize this data in a way that made sense. And so to do that, I had to put it into a format that really helped me define the relationships between all of the entities within my project. So that leads me into the cost distance optimization. To do that, I put it into a graph. And I had to define the graph schema for what that would look like for a referee to be assigned a match. If there's a match that's being played at a specific field, there are referees that have a cost distance to that field, and they will be assigned to the various referee roles that are required of assignment for that match. So when I did the calculation, I was able to develop some algorithms and some code functions that populated my graph with the various referees and the fields, and store the distance and time as properties in my graph. And I could use those distance and time when it came time for me to actually assign a match. Now, notice I haven't talked about distance weights yet. That comes next. So calculating the distance cost weight is a fraction of the cost distance for a referee to travel to a field over the pay from a match. So looking at how my distance traveled directly correlates to gas cost, and then the time traveled in a scale of the referee pay rate, I'm able to identify what the value of $1 for me is in relation to how much spent on travel per earned officiating a match. So as I make my way through my list of matches and go to finalize my assignment process, I'm left with a decision between a series of referees that each have a cost distance to a match, and am able to calculate the cost weight for each referee in comparison to a role. Now, this is really important because if, say, for example, here in this scenario here, Ludwig also has the opportunity to receive an assignment at another field. Yes, his cost weight for the center referee here is less, which is primarily going to be the most optimal assignment for him. He could have another assistant referee role that's less than that on another match. So we can use these relationships and define them to be able to identify what the lowest cost weight for that referee is. And as long as he passes the conditions of assignment that are outlined here, we're able to effectively assign them that match. Now, only one referee can be assigned to a match, or I'm sorry, a referee can only be assigned once to a match, and they must exceed the years of experience, and they can't have a match going on at the same time. Those are foundational for any assignment process. And so my model and my algorithm was able to produce these results. So for every match that was in the league schedule, I was able to assign a referee based on their cost distances to the fields that have the matches. Now, it's important to note that week to week, this may differ greatly. Not every week are matches played at the same fields, and so you'll have a wide variety of different fields that will need to be assigned to. But in this scenario, I scoped the project to a single day just to help make the data set a little bit more manageable. And as a referee, I can now see where I have to travel for my match. And as an assigner, I can understand the relationship of how assigning one referee first impacts the cost to another referee being assigned second. And they can optimize that assignment first by using the tool. But if they had to go in and manually do it, they could also assess the cost to a referee as well. And then because every referee assigner that I've ever worked with loves Excel tables, I made sure to produce a Excel output as well for ease of use for my referee assigners. So before I get into some of my works cited, I wanted to highlight, I'm sorry, before I get into my key takeaways, I wanted to highlight some of the works that were very beneficial to my project. Duarte's paper on the referee assignment problem and a proposed assignment model was really foundational for understanding how automated timetabling works and some of the gaps that are in those studies. Han and his study on routing and using cost distance really allowed me to understand what cost distance is and how to apply it to this problem. And then finally, as I mentioned early on, Ruler's study, while a shift away from some of the technical aspects of this project, was a very interesting study on the perception of distance, and I do recommend giving it a read. So some of the key takeaways. The project was successful in developing a methodology that assigned referees matches based on their cost distance. I was very excited when I finally got it to run and assign all the matches. There was a point where I thought I may not be able to make it work, and then it did, and I jumped for joy. And so now referees won't have to rely on my subjective preference, which won't prohibit me from receiving matches in places that say on one Saturday, I've only said I want to go to this subset of fields. Well, there's no matches there. So now I'm open to be assigned matches at other fields that I may not have been available to before. And if this was implemented in an actual league, many of the limitations that I encountered in my data set, it just wouldn't be there because they would have a full data set, which opens up a future research opportunity to really understand the spatial patterns in dispersion of fields across Columbus and how that correlates to the actual referee populations. And of course, this methodology is not limited to just Columbus, Ohio, and it can be implemented across various scales, the local, state, and regional. But the cost distance metrics may be more severe, which that's to be determined how impactful that would be and what the success rate of this is, or if we would just end up finding that, yes, clustering occurs around fields and no referee from Columbus would ever get assigned a match out in Dayton. And then, of course, since this is one parameter of a much larger referee assignment problem, I'd be very interested to see how this metric plays into other models where they've gone through and they've outlined the 1 through N reasons why a referee should or should not be assigned to this field, whether it's because they have a bad relationship with the coach or they are working alongside or they're about to ref their kid's game, all those different reasons that we could come up with. How does that embellish this project and how does it make it better? And then something in the back of my mind that I might explore myself in the future is how does this lay out for a fully automated process and using a more machine learning approach where we can look at the whole schedule in its entirety, not just single instances of matches at a single time, and assign the entire schedule in a fully optimized way. And so at this time, I'll go ahead and open up for questions.
All right, Matt, thanks very much. Very practical investigation.
Thank you.
Looks like you have a question in the chat window.
Pull that up. There's the chat. And one second. Oh, there it is. Aha, thank you, friends. All right. What did all the referees think of your project? Kind of kidding. Did you share this with any of them? And do they agree that one destination cost matrix is beautiful? Yes. So, Beth, that's a great question. I had an opportunity to talk to about this project with some of my referees on the field, and they were all very enthusiastic about it. I have not found a way to share this data with them. And there's two reasons for that. One, we haven't gotten to the discussion forums, so I'm going to figure out where to publish that yet. And then two, the assigner that I work for, he runs his own business. And so I would have to figure out how to basically publish this algorithm in a way that doesn't encroach on his business, or else I may not receive further assignments myself. And I want to keep a good relationship with my assigner. So, but I do intend and would like to find an opportunity to present this methodology to the referee community because it is it is impactful, but I would want to be smart about it and make sure that it's done more broadly. Yes, exactly. Thank you. I saw
Yeah.
someone else has a hand up.
I didn't see
Yeah,
anybody.
it is me, Koray,
Oh, yep.
Matt.
Hi.
It's very interesting. As an Franklin County resident in Columbus, Ohio, it was interesting to see all the fields on the map.
Yeah.
My question is your output is only the Excel sheet? Can we support this wonderful study with some additional visualization for the decision makers or some public audiences? Do you have any opinion on that?
Yeah, I do. So early on in our master's program, we took the design class where we actually looked at how do we design a full project for something like this. And this was one of my use cases for that. And so there's an opportunity to have a whole web app solution where as referees make assignments, there's a web app on your phone that pushes their assignments out to the referee, shows them where they need to go. And then of course, there's a whole integration with the referee processes and everything that we have to do. But being able to get it right on their hands, right into their pocket, but also by further developing the graph, storing all of our results in that graph, we'll be able to learn more. So as referee assigners could use this tool, it would build out the knowledge base for how we assign these matches and maybe create a better experience for those referees as well. Now, I know static maps aren't necessarily the most useful for a day-to-day, but it is also very difficult to visualize graphs in general. So we do have to be smart and wise about how we present that information, or else it can be very confusing to the end user. But thank you for the question.
All right. Matt, thanks again. If you could put your contact info in the chat window in case someone wants to follow up with you later, that would
Sounds
be
good.
great. And then, Corey, if you're ready, start sharing your screen. You can go ahead and do that.
Let me share it.
Very good. So whenever you're ready, you can begin.
Yeah, I think it's good. All right. Hello, everyone. Thanks for the very good presentation before me. It was exciting to watch and see your projects. My name is Koray Oskay. My capstone project is developing an AI-supported web mapping application for exploring global submarine cable systems. A little bit background about me. I live in Dublin, Ohio, near Columbus, and working in surveying and mapping company, SAM, as a phase manager there. And I'm working in renewable energy and the telecom project. I'm the registered surveyor intern with Ohio Board of Engineers Surveyors and associate member of the Professional Land Surveyors of Ohio. Before this MGS program, I graduated and completed from the Geospatial Programming and Web Map Development, my BS and MS degree from Istanbul, Turkey. And I have over 20 years experience in telecommunication and the fiber optic infrastructure, global connectivity projects worldwide. I contributed to some of these international projects, like in Middle East and the Mediterranean area. These are the regional connectivity infrastructure was very important for the region and the countries, like GBI cable system, RCN cable system, Metnatilius. These are some specific cable systems there I was working before. The project goal is to create a web mapping application as a proof of concept that lets users talk with the map and explore submarine cable system in a new way, and to have map instantly respond with the visual and textual information for their natural language queries. With that way, the users will able to talk with the map and map will answer them interactively through this communication. give me a little bit information about submarine cable systems. These are the very vast networks of cables crosses ocean floor, connecting continents, carrying very big amount of data traffic. These submarine cable systems are responsible for transmitting 99% of our international internet traffic and handle about $10 trillion in financial transaction in every day. This map you see on the slide isn't based on the real world data. It's actually the hypothetical example generated by AI. So it's not reflecting any actual submarine cable routes. But of course, there are several organizations provide the maps for these underwater networks. But these maps, they often need more interactivity and the ability to easily explore many details of this important infrastructure. That's where my project comes in. The idea is to use the AI and integrate it with the mapping technologies to transform how we can query and visualize these critical systems. Let's take a look at some of the key studies that was very important for this project. The first one, the study by Lee and Ning that explored the use of large language models for analyzing GIS data. They created a prototype called LLM Geo that could answer complex questions about the geographic relationships. For example, it could determine the population living near hazardous west sites and display this information on map. Their prototype integrates an LLM with a GIS platform and enabling user to interact with this data and perform spatial analysis tasks. Again, using the natural language instruction, which is very, very interesting. Another project, GeoQA geographic question and answering, focused on making geospatial data accessible through the natural language queries. It could translate a question into format that could retrieve and display this information from a knowledge base, like a Wikidata. But the most important thing is that through the Sparkle query language, that's the model can transform this query to that language, and additional sources like OpenStreetMap, CityGML also can be accessible with that way. This research highlights the power of the generative large language models to access the real world data with human language queries through the structural programmatic language translation. Another key component of this project is automating this geospatial task using a function calling with the model semantic understanding capabilities, which is very, very super important element for my project. GeoGPT developed by Zencator provides a framework for this, and the combining semantic understanding of this model with GIS tool and functions. And by using these functions, the model provides the correct answer, even for complex spatial queries, and delivering very accurate and real-time answers to the users. There's one example in this query. It's really complicated in this task. It's required many steps in the spatial analysis to get the correct answers, but the model can do it automatically by following to this function declaration and calling mechanism. All right. After that research, I have investigated some platform and found that the Google platform is one of the best. And I have deployed this project on Google platform using a serverless architecture and fine-tuned and generative large language model in Vertex AI platform, which interacts with the data set and also grants the model's responses from the Google search world knowledge. With that way, I utilized this very popular platform nowadays, is offering a lot of model options. I made some experiments and I choose the Gemini 1.5 Pro 1 model. It was very successful. Responses was given to me in my experiment and choose and implemented my application. Let's look at data. In this project, the data comes in structured and in unstructured formats. The structured data is global routes of submarine cables and stores some basic attributes and also very important coordinate points, latitudes, longitudes for define the submarine cable system paths. But unstructured data is totally different format as we don't use in GIS a lot because it was very difficult to process before the AI models in the past. But with that project, the platform used this some PDF documents from the Submarine Telecom Forum Almanac or some other industry reports. And in addition, the system is being fed by the Google search for the world knowledge to transfer the model to access to some related web pages, retrieve their grounded responses by real world references. Basically saying the data is relying on these two different type of data format. For data sets preparation and the quality control, I use the ArcGIS Pro and I use the Python script to convert the GeoJSON data set into a JSON line format, which is this format required for importing data to Google Cloud Platform. And I also the unstructured data, which are the PDF documents, are stored in another data store in the Google Cloud. And all of these data sets are accessible right now in Vertex AI platform. This application has been built on server-side backends and the client-side front-end architecture. The backend runs on a Node.js runtime environment and includes the API key management and the model configurations. The natural language queries are being also processed and turned into the responses in the backend. On the front end, there is an interactive map, of course, that use the modern HTML, CSS, and JavaScript for user interface design. And I utilize the Mapbox GLGS API for this purpose. And users can interact with the system through a chat interface, and the results appears in text on the chat panel, and the model responses related visualization can be seen on the web, on the map. All right, this is a little bit detailed, but I will not go in a lot. This just the diagram is very essential for the application logic, showing the flow of how the proposed application and the AI model process the user's request. That diagram and explanation can be found in the Google webpage, and it is very, very good explanation is that. But basically, the functions, declarations can be understood by the model in query in natural language to decide to use it, not to use it, or maybe skip it. That is the perfect new way. Even I was in the former programmer, that is new way to write a programming code with this model. Results. First of all, the proof of concept application is accessible at the following link. All of you are welcome to go in and test it. I will be appreciate any feedback, would be very valuable for me for future enhancements and the versions for this proof of concept application. Also, the functionality of the system for natural language queries and the user assessment feedback, I will explain in a couple of next slides. The first thing, the application give responses with that type of interface in the link for specific cable system. You can ask in the chat panel to any cable, submarine cable. In this case, the map the CMV5 submarine cable system user is queried, and the system on the chat panel given a lot of information about that. And simultaneously, the map shows the given information on the map on the fly. Our system is also successful, very successful listing cable system landing in specific location. In this particular case, the user is asking to landing cables to the Maldives, and the system is showing all the Maldives cable system automatically on the map, and the instruction given by the model, not instruction for information given on the model chat panel about each cable system. Again, the system is very successful, identifying specific cable system between countries. In this particular case, the user asked a question, which cable system connects South Africa and Spain? The system generates the information. S83WSCS cable system is connecting, giving all the landing station information. The user can zoom in, zoom out, and to see and investigate on this land station, and also ask some additional queries to understand better what is going on in between these two countries. On the other hand, that is another example. The user is asking more particular details about the cable system. In this case, is Nautilus cable system in Mediterranean Sea is connecting many countries. The system's response is very valuable: ownership, location, land point, connected countries, and more. And user can be happy about this given level of information or ask more details to get more feedback from the system. And that information can be visualized on the map based on that context. The last thing, attribute-based mapping and the queries with natural language, it's coming very wonderful opportunity for the next upcoming version of this map, because attribute-based questions would be very interesting for users. For example, in this particular case, the user is asking which is the longest submarine cable in the system. In the chat panel, it says that to Africa is the 45,000 kilometer is the longest one. But also the system is adding additional information. Before that, CMV3 cable system previously considered the longest one with the 39,000 kilometer, but now it is not. This is some additional way how you can get more insights from the map with this type of interaction on new web map interface, which the other cable network mapping applications cannot give these details of information. Okay, very quickly, I make this proof of concept application available to some user community, and 11 users are participated to this assessment. Some of them was the both domain experts, some of them is non-expert. Task-based usability testings was given, and all responses were graded for the 1 to 5 scale. Pre-task questions, I just highlighted 4 things here. The first thing is the pre-task questions. The course 1.8 is a little bit low, is suggesting that the familiarity with the submarine cable systems for this user group is very limited. So the system should be helpful to get them to effective query and to get the insight from this proof of concept application. And the other highlight is 2.7, their confidence in accuracy for answer was low, lower than 3, because these guys probably doesn't know anything about the submarine cable system, and they don't know if the model is giving them as response correctly or not. This that feedback is very valuable for me, because in the next version, I can reference the model responses with the cited or reference sources to convince the user community the model is giving them a correct answer. At the end of a lot of tasks, there was a 5 tasks, to be honest, not too much, but that was very interesting for them to play a little bit on the interface. Ease of interaction with the chat system, get high score, and willingness to reuse the system is get the 4.8, very good score, and I was very happy about this feedback from the user community. In conclusion, this project is provided a proof of concept for integrating AI language models with web mapping technology. It is new trend, new upcoming way, how we are gonna interact with the geospatial data. And AI has the potential to transform our interaction with this data and the maps. Also, I'm thinking visualizing, analyzing submarine cables through this type of natural language queries was not exist before than this prototype. And I believe it's enhancing the user experience, and some feedbacks from this limited user assessment participants give me this opinion about this upcoming trend. This was hopefully not too long. I didn't hopefully pass a lot to my time, but thanks for your listening to me. And I'm opening for any of your questions.
All right, Cray, thank you very much. That was a great presentation. I know from having worked with you throughout the semester that you faced a lot of challenges working with the technology, so congratulations on working through all of that.
Thank you. It was challenging time, and I'm very happy to learn that this AI technology, an upcoming trend, while I was developing this application and the completion of this capstone project. And thank you for your wonderful guidance and the helpful comments through the development process.
Happy to help. Glad to see
Thank
it come
you.
together. So looks like you have a question in the chat window.
Okay. Well, that is a great question. Matt is asking about the Franklin Candy has a lot of unstructured data sources. And my answer, that is the new upcoming trend and the wonderful opportunity to process this type of unstructured data with the AI models very quickly, very efficiently, and transform them, the structured model, to make them ready for spatial analysis. That is wonderful opportunity. And if you want to be involved in formal way, how we can develop these type of things, I'll be happy to be talk in details with you, Matt.
One question that I had was, so you've reached the stage where a user can ask questions of the data through the natural language, the interface, type in the question, so forth. But have you thought about how you can take map-based queries? For example, I was trying to think of something like this. So in other words, instead of interacting through a text box, have some way that they could, click on a map, draw a bounding box, or some kind of interaction in that way. I know that's a completely different approach, but have you thought about that kind of interaction?
That's the great question, and that's true. Some of the users had this feedback in their assessment and was asking how they are gonna do the opposite queries from the map to the chat panel, not from the chat panel the map. It is perfectly possible. I just use in this time Mapbox GLGS, which I had limited experience on that. I am very well experienced in the ArcGIS API, but in this project, I prefer to increase my skill set in other API. At Mapbox has limited widgets and agents in their platform. If I can utilize the JavaScript API for the ArcGIS SDK, there are lots of good way to pass these queries from the map to the chat panel and through the AI model. Unbelievably, at this time will be interesting product, and I need to focus on this in the next coming version. But yes, this feedback was given to me by the user community as well. Thank you for that. That's one.
Looks like Tiffany, if you have a question or a question, go ahead.
Yeah, so I hopped onto the website when you dropped the URL. It's pretty cool. I had a question. I know nothing about AI at all. Did you have to build in the language for the questions? Because I typed in, I have a personal connection to Chile, and my dad's flying there right now. So I typed in what is the connection between Florida to Chile, and it said it was, I can't tell you about flights and all of that, but I can tell you about the cable system, and it couldn't generate the map. But then I added, what is the cable connection or whatever from Florida to Chile? Did you have to add in specific language to do that? I'm not sure how that works.
The system language mean is the translation between the Spanish or Turkish or English. Are you asking this type of language or the kind of way of the grammatical
the way?
Okay,
yeah, because
way.
I asked what's the connection between Florida to Chile, and it didn't come up with anything. But then I asked what's the cable connection, and then it popped up.
In the user test, we have found the two glitch in the platform. I need to repair that. The first thing, if the system's not giving you the response with you, please refresh it. Because AI model sometimes saying that I'm not giving information. This is the timeout problem. I need to update it. Second question. I used some tuning techniques, and it says the prompt engineering for development. in this instruction, I need to teach the AI the cables once the user is mentioned is referencing the submarine cables, connectivity cables, not electric cable, not internet cables they use in terrestrially at home or something. Sometimes the model can confusing the users. If you renew your query and openly ask them submarine cable systems in between these two countries, it will understand better. Definitely, it's an improvement item I need to develop and to make these corrections in the next version.
Yeah,
That
thanks. That's
cable
pretty cool, though.
mean is little bit sometimes large, not always, sometimes large, and they say that cable is means a lot, and I don't want to give you everything. And if you want to get something, everything, tell him to let me get exhaustive list of the cables in this specific location. At this time, the waiting timer will increase the 30 seconds. You will get not able to get the answer in 3 seconds or 7 seconds. It will take longer time, maybe 1 minute, but at the end, it will get for you.
Pretty cool.
Thank you.
Looks like Marcella referenced an article that may be of interest to you.
Yeah, no question. It was just in case I saw it recently and remind me.
Just
remind me of it.
GeoG. Yeah, that is this article was in my reference in one of the slides as I mentioned about the GeoQA, Geo question and answer. That I'm very familiar of this article. It was a part of my investigation. Thanks for sharing. That's an amazing. And many of these research and articles is very new, relying on 2023 and the 2024, because this trend is just started.
All right, Corey, if you could put your email in the chat window in case someone wants to contact you later and to talk about this, that'd be great. Otherwise, I'd like
Thanks
to
for listening.
I'd like to extend a thanks for all the presenters. Great job. Glad you were able to get things wrapped up here. And we have another presentation session tomorrow starting at 12:30. There'll be another set of 870 presentations, so you're all welcome to attend and listen in. Otherwise, I wish all of you a good day, and hopefully we'll see you tomorrow.
Thank you.
Thank you, Fritz. Thank you, Marcella.
Thank you for everybody. Have a good night.